integers. I'm just sharing my screen. So can you see the screen?
Yeah, it's visible.
Alright, so I was just explaining how we got the range of integers. So we know integers require 4 bytes of memory space, that is equal to 32 bits. So every bit can either save 0 or 1. So if we just do 2 raised to power 32, we'll get this value. Now I was explaining over here that when we go down and we check in unsigned integer, we have the value 0 to 4 2 9 4 9 6 7 295. This ends with 296, this ends with 295. So our 296, it's over here, it's ending with 295, as they have subtracted 1 from the maximum value, so that in unsigned integer we can use the value 0 also, right? So to over here, this is the range from 1 till the maximum value. But if you also want to have 0 as an option of any integer value, so if we want that 0 can also be an integer value, then we can just say 0 to we can just subtract 1 from the maximum value, and 0, we will be able to set the value of our integer as 0 also. And in a normal integer, we can just divide this by 2, right? So half negative, half positive. So as you can see, it's ending with 648. That is a negative value, so negative 2 1 147 and all, till in the end we see 648. But over here in the positive one, we in the end we see 647, because of the same reason. Because over here we are getting the range from 1 till the maximum value, but we also want 0 as an option. So we'll just subtract 1 from the maximum value, so that we can set the value of the integer to be 0. So we'll just subtract 1, so we'll get 647 in the end, right? So 2147 483 647. So that tells us the range of the integers. So to take out the range of character data type, character is usually 1 byte. So if we just say 1 byte is 8 bits, so if we say 2 raised to power 8, we get 256, right? So if we divide that by 2 in a signed character, where we can have negative and positive values, we get 128. So 128 values are there for negative and 128 are there for positive. But because we for the same reason, over here we are getting 127 instead of 128 as the maximum value of the character, the signed character, as we also want 0 as a value, as 0 can also be a value of the character, so we'll have to decrement 1 from the maximum value. So we get minus 28 to 127, or 0 to 255. So if it's an unsigned character, then the values can be 0 to 255, because we were getting from 2 raised to power 8, we were getting 256. So 256 is basically 1 to 256, but we'll have to subtract 1 from the maximum value to get 0 also, to be able to use 0 also as the character value. So this was the character about the character data type and values. So is it clear?
Yeah, it's clear.
Alright, so next we can move on to the Boolean data type. So Boolean data type is used for storing Boolean or logical values. So it's either saving true or false. So a Boolean variable can store either true or false. The keyword used for Boolean data type is bool. We'll use bool, and mostly it's saving a 1 byte, right? So mostly Boolean occupies 1 byte of memory, though it does not need to, as the value of a Boolean can either be 0 or 1, that is true or false. So it does not need to save 1 full byte, but it does mostly occupy 1 byte for the Boolean data type. Alright, so we already know the use of Boolean. We use it in the conditional statements like if, else, and all, right? So next we can move on to the floating point, that is represented by the float keyword in C++. So the floating point data type is used for storing single precision floating point values or decimal values. They used to store decimal values. So the keyword used for the floating point data type is the float keyword. So float variables typically require 4 byte of memory space. So 4 byte of memory space is equal to 32 bits. So if we do 2 raised to power 32, so let's just go to the maximum value of the float. So float's maximum value is this. Let's just copy paste this to see. So uh, it's just showing in scientific notation, but the float's maximum value we get from 2 raised to power 32, like we got for the integers, right? So floating point value is basically a decimal. It can save decimal values. You can save decimal values in your float data type. Similarly, like floating points, we have double floating points. So double floating points is just a large float value. It can store large float values. So double floating point data type is used for storing double precision floating point values or decimal values. So the keyword used for the double floating point data type is double. So double variables typically require 8 bytes of memory space. So double also stores floating point numbers. Float also stores floating point numbers. The difference is the floating point numbers have a smaller range than the double floating point numbers. You can have many more numbers in a double floating point than you can have in your floating point as values. So we already saw double floating point, boolean, character, integer in our basic course. Next we have void. We also saw void in our basic course. It is used with function. So void means without any value. So void data type represents a valueless entity. A void data type is used for those functions which those for those function which does not return a value. So whenever we don't have to return a value from a function, we just give a void in the place of the data type of the return value. So a void basically tells that the function won't be returning anything. So it's mostly used with functions only, where you give the return type, there only it's mostly used. So next we have the white character. That this is a new data type for us. White character data type is also a character data type, right? But this data type has a size greater than the normal 8-bit data type. Your character is 1 byte or 8 bits, but its white character size is greater than the 8-bit data type. It is represented by WCART instead of just char, right? It is generally 2 or 4 bytes long. So it's saying 2 or 4 bytes long. So when compiling your code from some compiler, it may consider wcat as 2 bytes long. In some other compiler, it may take a wcat as 4 bytes long. So it may occupy 4 bytes for wcat. One compiler may occupy 4 bytes for wcat. Another compiler may occupy 2 bytes for wcat. So it varies from compiler to compiler for our byte character. And then we have the size of operator. The size of operator is used to find the number of bytes occupied by a variable or data type in computer memory. So if we say size of int, it will tell us 4, that occupies 4 bytes. If we say size of char, it will tell us 1 because it occupies 1 byte, right? So size of will tell how many bytes a data type or a variable occupies. So, is this all the data types in brief? Are these clear?
That's clear.
All right. So next we have an example where we have int m and then we have x50. So from x50 we are creating an array, right? So we see out size of m that returns 4 because an integer occupies 4 bytes, and when we are see out this we are just printing the size of our m variable. So it returns 4 as the variable will be occupying 4 bytes. Now size of x we get 200, right? Which is the number of bytes occupied by the integer array variable x. So this is an integer array with 50 elements. Every integer occupies 4 bytes. So 50 into 4 we get 200. So this full array is occupying in total 200 bytes. Uh, so uh, Is the example clear? The integer m1 is just telling us the size of an integer, but the array one, is that clear?
Yeah, I got it.
All
Very
right.
clear.
Thank. So the size of variables might be different from those shown in the above table depending on the compiler and the computer you are using. So the size, like I told about white character, may vary from compiler to compiler, right? So here we have an example of all the sizes of every data type. So when we see size of char, we'll get 1. When we say size of int, we'll get 4. When we get size of long, so long is basically, long is our type modifier, right, that we are gonna see over here in the next examples. So long is a type modifier, and we are gonna look at it. We can just for now ignore long, right? Then we have size of float, that will give us 4, and then we have size of double, which will give us 8. So let's just run this ourselves also, so that we'll just get the sizes of every data type. Right. So it has given us the result. It tells us the size of char as 1, the size of integer as 4, the size of long that we're gonna see as 8, size of float as 4, and size of double as 8. So next we have data type modifiers. So as the name suggests, data type modifiers are used with built-in data types. So they are used with data types to modify the length of the data type, of data that a particular data type can hold. So for example, you can use signed with integer. So by default, integer char are all signed, integer char long that you're gonna see. That's a prefix. They are by default signed, integer char long, etc. Then we have unsigned. So unsigned, we can use on integer, we can use on a char, and we can use on a short. So long and short, we can use with other data types, and we can use them independently also. So we are guys gonna see that in the examples. Next we have long, that we can use before an integer or double, which will expand the memory, expand the size of an integer or double. And then we have a short modifier that we can use before integer, that will basically reduce the size of your integer data type, right? So there, it's telling us that data type modifiers available in C++ are signed, unsigned, short, long. So the below table summarizes the modifier size and range of built-in data types when combined with the type modifiers. So we have short integer. So it decreases the size of of our integer. So when we give short before int, the size of integer is not taken as 4 bytes, it's taken as 2 bytes, right? And the range, we can calculate ourselves. If it's 2 bytes, that means 8 bits per byte, that means 16 bits. So 2 raised to power 16 will give us 65536, and the maximum value for an unsigned short integer is 0 to 6. It's 65535, right? So it's 65,535, but over here we are getting 65,536. Why? Because of the reasons we discussed above. Because over here we are getting the range, the minimum value. When this is the maximum value, the minimum value will be 1, but we also want 0 as an unsigned short integer value, right? So to have 0, we'll have to subtract 1 from the maximum value. So minus 1 will give us 65,535, and that is the maximum value for an unsigned short integer. For a short int, the value that yeah so short for the short int, the value is divided by 2. So half for negative, half for positive. So we get 32,768, and that is in the negative value, because negative value starts from -1. So it goes till minus 32,768, but it only goes to 32,767, because it also has to include the value 0 in the positive side, right? So it will subtract 1 from the maximum value in the positive side. So that will give us 32,767. Just for the inclusion of our number 0, we have to subtract 1 from the maximum value. Alright, so next we have unsigned integer, no, normal unsigned integer, not unsigned short integer, normal unsigned integer, and that will basically only have that will only contain positive values of integers, right? So it's 4 bytes and 0 to 4, this long number. We already calculated unsigned integer in the previous class and this class also. We also calculated integers values, how they are coming, but now you can see the long integer. Long is intended to be a modifier of your data type, but as you can see over here, when doing long integer, the size in bytes remains 4 only, and the range of values of integer also remains the same. Why? Because integers are by default long, right? So integers have by are by default long. So if you give long once before them, it won't bring a change, right? So they're by default long, so if you specify long before integers, it won't be it won't change the size in bytes or the val or size in bytes of your integer, or it won't change the values it can store, right? So long integer and integer are the same thing. If you do unsigned long integer, it's the same as unsigned integer, right? But now you have long integer. Long integer did not giving long once before int did not make a difference, but giving long twice is making a difference. When you give long twice before integer, then it occupies 8 bytes for your integer, right? So it will be 8 bytes means 8 into 8, 64. So if we do 2 raised to power 64, we'll get some very big number, right? And if we just divide that by 2, we get the value for the signed sign long int, right? So it's minus 2 raised to power 63 to 2 raised to power 63, right? Minus 1. So it's showing us 2 raised to power 63, right? So 8 bytes is 64 bits, so it's showing us 2 raised to power 63. So I'll just check on this and I'll get back to you why it's 2 raised to power 63 to 2 raised to power 63, why it's minus negative 2 raised to power 63 to 2 raised to power 63. So I'll just get back on this in the next class. But right now we know how to calculate the value of our of our data types, right? So what the range of values our data types can store, we know how to calculate that. It's 2 raised to power how many bits is occupied for your data type, right? So next we have unsigned long integer. So it's basically an unsigned long integer. So it occupies 8 bytes, but its value is very big, right? So mostly we won't require these big values, these big data types or values, but in advanced programs we may require such big values to be stored in a variable. So that's why these modifiers are there, which can modify our data types capacity basically, right? So it's 0 till this much. So unsigned tells that no negative, only positive, right? Next we have signed character. Signed character is by default, when you give char, it's by default signed character only. It occupies 1 byte, so it's minus 128 to 127. Unsigned character is not by default. You have to give unsigned before char to make it an unsigned character, right? And it occupies 1 byte and it's 0 to 255. Next we have float. Float is of 4 bytes, right? And its values is from minus 3.4 into 10 raised to power 38 to 3.4 into 10 raised to power 38, right? So it occupies 4 bytes, that means 32 bits, right? Then we have double, that is an expansion of float, right? So it's a bigger float value. It occupies 8 bytes, right? That is 64 bits, right? And it starts from this value and goes till this value, right? So in double you can save a very very big number. And then you can also use a long a type modifier before double, that will increase the capacity of double, so it will make it 12 bytes, and 12 bytes you can save this bigger number till this big number, right? So in doubles already you can save very big values, but in long double you can save even more bigger values. And then we have wcat, that is either 2 bytes or 4 bytes, and it's one wide character, so it can have it's a superset of your char data type, right? It can save many more characters, unlike your char data type, right? So char is basically limited, and wcat is a superset of your char data type, right? So we just saw all the sizes of our data type and the range. So do you have any doubts?
No, it's clear.
All right, I'll get back to this long integer in the next class. All right. So above values may vary from compiler to compiler. So this website Geeks for Geeks is also telling us that the above values may vary from compiler to compiler. So in the above example, we have considered GCC 32-bit, right? So GCC 32-bit is a type of C++ compiler. So these data types, these sizes of data types are considered like this only, like these are the sizes of these data types in GCC 32-bit compiler. So when the code is compiled from a GCC 32-bit compiler, then the sizes of these data types will be the sizes that are mentioned in the table, but these sizes may vary from compiler to compiler. So we can display the size of all the data types by using the size of operator and passing the keyword of the data type as an argument to the function as shown below, right? So that is shown below in this example over here, right? So the size of data types is varies from compiler to compiler, right? So now to get the range of data types, refer to the following chart, right? So to get the range of data types, we can see this following chart. So over here we have this chart. So in we have we have IOStream library to use cout and all. We also have a limits.h library, right? So that's also a header file, right? That is defined to find the range of fundamental data types. So it contains all these constants that will give us that will tell us the range of our data types, right? So like unsigned modifiers have minimum value is unsigned modifiers have minimum value is 0. So the language I think is wrong. Unsigned modifiers have minimum value is 0, right? So so no macro constants are defined for the unsigned minimum value. So for our unsigned over here, what they're saying are unsigned values like unsigned char, unsigned int. They don't have a minimum. They don't have a constant. These constants in the limits.h library are called macro constants. So the unsigned variables like unsigned integer and all don't have a macro constant for the minimum value of an unsigned integer or unsigned char, because every unsigned data type will unsigned data type's value will always be 0. So the minimum value of an unsigned data type will always be 0. So that's why there's no macro constant telling us that the unsigned data type value is 0, right? So basically the when we give unsigned before any data type, there's no macro constant to there's no constant defined to tell us the minimum value of our unsigned data type, as unsigned's value is always 0. That what it basically means, right? So we have many types of macro constants that we can use to actually know the ranges and all for our data type. So like char min, so the minimum value of an object of type char min will tell us the minimum value of char that we can have. Char max will tell us the maximum value for our variable of type char. Then s char min, the minimum value for an object of signed char. This will tell us about signed char, right? So for signed char it will tell us the minimum value, and s char max will tell us uh, the maximum value for signed char, right? Then we have uchar max. Uchar max is the maximum value for an object of type unsigned char. You have unsigned char max. We don't have the minimum value as it's always zero, but we do have the maximum value macro constant that tells us the maximum value of our data type, of some data type. So uchar max will tell us the maximum value for an object of type unsigned char. We know it's 255, so we can have 255 as the maximum value of our char data type. Then we have char bit, number of bits in a char object. So char object is 1 byte, that is equal to 8 bits. So char bit will give us 8. Then we have MB len max, maximum number of bytes in a multi-byte character. So we're gonna see MB len max. So this will tell us the maximum number of bytes in a multi-byte character. So if you have a multi-byte character, it will tell us the maximum number of bytes in it, right? So we're just gonna test all of these also. We have short min, the minimum value for an object of type short int. Short int is of 2 bytes. We let's just go over here. Short int is of 2 bytes, and its minimum value is negative 32,768. So this short min will give us negative 32,768, right? Then we have short max, so the maximum value for an object of type short int, so that is 32,767. Then we have use short max, that is the maximum value for an object of type unsigned short, right? Unsigned short integer, so that is 65,535. Then we have int min, the minimum value for an object of type integer. So it's the minimum value for an object of type integer, and that will give us negative some 2 million. Yeah, so it's this value, and the or int max, that will give us the maximum value. Then we have the u int max, that will give us that 4 million something value, as it will give us the maximum value for an unsigned integer, that is this. Then we have long min, the minimum value for an object of type long integer. So long min will give us the minimum value for an object of type long integer. We know long integer and integer both are the same things, right? So by default integers are long. So long will min will all give us the same value as int min, right? Long max will give us the same value as int max. U long max, unsigned long integer, will give us the uh, uh, same value as u int max. Then we have L long min, that is the minimum value for an object of type long integer, and L long max is the maximum value for type long integer. We saw that double long, that when we give long, the the range of our data type integer is changed then, but if we only give long int, the range of the data type is not changed. And then we have the u long max, that's the maximum value for an object of type unsigned long integer, right? So that's a very big value that we saw, 18 million some, yeah, this value, right? So you your this ul long max will give us that value, the maximum value for an unsigned long integer. Alright, so these are all the constants. We don't have to remember these constants. There are many constants. They will just help us while programming, and they will let us know what how much space is a data type occupying. And this information is important, as we can directly deal with memory, and we have to do a lot of processes ourselves in C++, like garbage collection and all. Garbage collection, we can directly manipulate memory, so it's important to know the maximum and the minimum values of our data types that we are using. So the actual value,
Okay.
so is this clear, all these so
Yeah, they're clear.
yeah, so these are very basic constants that we won't use that much, but we'll just use them to know how much space is one data type occupying, right? So the actual value depends on the particular system and library implementation, but shall reflect the limits of these types in the target platform. Right. So the actual value actually depends on the compiler you are using, or on the system you are, right. But these but so the actual value I'll just read that once again. The actual value depends on the particular system and library implementation, but shall reflect the limits of these types in the target platform. So this reflects the limits of your type in the target platform, right. So on any platform you are, it will reflect the limit of your values, like what is the limit of the unsigned long integer, what's the limit of your long integer, and so on. So long min, long max, and long max are defined for libraries complying with the C standard of 1999 or later, right. So this is telling us that these three constants, long min, long max, and long max, are only there present for they are only there for C++11 and above, right. So people who are using C++11 and above will only be able to use these constants. In lower versions you will not be able to use these constants. So here's an example of using all of these constants, the macro constants. So we have to include the limits dot h, right. And then here are the full examples, and then we have also the examples of different char data types, bools, float, double, long double, and integers, right. So we have many examples now, right, and we are moving on to the coding part of this. So we'll continue the data types examples tomorrow in tomorrow's class, as today the meeting is only of 40 minutes, and so we should continue tomorrow then,
Yeah, okay.
at the same
Thank
time.
you. Bye.
At the same time.
Yes, same time.
All right, thank you, bye.
Bye. Thanks.